Hello, everyone. Welcome to our meetup. Today, we're in the VMware office. So thanks, VMware office, for hosting us. Thank you, Dimitar and Polya, for organizing everything. We have two talks for today. Mikhail will talk about auto-scaling with Tanos, and the guys on the left side will talk about integrating with Envoy and virtual appliances. That's the team. That's me. We have Spas from MariaDB and Vladimir. We're behind the organization of that meetup. How you can stay in touch with us? We're currently using Meetup. You can find us in Slack. All these are links on the slides. So we have a dedicated Bulgaria channel in the CNCF Slack. Soon, we have to migrate to the CNCF community. So please register yourself to the link below. We'll stop using Meetup.com and we'll migrate to the community so we can slowly transition to the standard for CNCF. Upcoming event is the KubeCon NA 2022 in Detroit. You can use that code on the screen to register yourself. I think it will give you 20% off from virtual and in person. Upcoming events in Bulgaria next month, we have OpenFest. It's going to take place in 15th, 16th of October in Sofia Tech Park. If you're interested, they published the agenda. There are plenty of talks about containers, Kubernetes, so you should visit. That's a note from our side. It's a website called Kube Events. It's an aggregator for all Kubernetes and cloud native related events. So if you don't want to miss any future events, you can register and you can get your daily reminder in your email box about future events. Next meetup is going to take place in the Kronis office on 24th of November. It will be in person, finally, so we can meet each other, have some beers and some food. And yeah, Spas, you want to talk about?
Yes. Thank you, Orlin. I wasn't prepared for that fast introduction, by the way. You did it under 2 minutes, by the way. Yeah. Okay, I just want to mention that we are open for proposals for the next topics in our upcoming meetups. You can use the forum, or you can reach out to us directly over Slack or over meetup.com. And I would love to see some topics like GitOps or multi-cloud, multi something. So be open with your ideas, and we are waiting for you. And now, because Orlin was too quick with the introduction, I just want to mention that today on this stage we have Misho, who is working with us in MariaDB, and Misho we're going to talk about auto-scaling in terms of very different things, but covering also some perspective from the multi-cloud and multi-environment with Tanos. And also we have 3 folks from VMware that are basic. So they are basically maintainers. They are also enhancing and using Envoy, and they're gonna talk about endpoint availability with Envoy. So thank you for attending to this live meetup. Also, thank you to everyone that will watch the recording later. And Misho, I think you can.
Yeah. I can begin.
Yeah, just one remark. The live chat with the stream is up, so if you have questions, feel free to ask them there. Follow the chat, and we can ask the questions live at the end of the session. So go ahead.
Yeah. So hello, everyone. It was very nice that the introduction was so quick, because now I feel I have all the time I need for this talk. As Spas and Orlin said, I will be talking about multi-cloud application autoscaling with Tanos. And I could have added some other things in this title, but it's plenty of stuff there. So let me talk about what I'm going to talk you through. So ever since I was starting with working with Kubernetes and cloud, I was very passionate about automating stuff, and about autoscaling in particular, because I think autoscaling is what we are all here about. What's the purpose of being a DevOps? Because this is the next level automation in terms of all the stuff that we are forced to do in our day-to-day work. We can automate by using autoscaling. And in Kubernetes, the first part of my presentation will be about what autoscaling is in Kubernetes. So yeah, there are three terms that we need to know about autoscaling here. There is the horizontal pod autoscaler, which is the thing I'm going to talk about. There is the virtual pod autoscaler, which I haven't seen anyone used anywhere, but I know that there are some legitimate cases in which it can be used. And the cluster autoscaler, which is not part of this discussion right now, but I'll briefly mention something about it in the process. So I'll spend a bit about talking about the autoscaling and horizontal pod autoscaler in particular. First of all, I have one slide about the Bible. So there is a very cool page in the, I think one of the best places you can learn about Kubernetes nowadays. It's the official documentation, because I find it very useful sometimes. And this particular page about horizontal pod autoscaler, I think has everything you need to know about the autoscaler itself. And I have personally read it several times, and every time I read it, I find something new and exciting there. And yeah, I have shared, I think here, a QR code to the page. Check it out. If everything I've been introducing here in this discussion sounds interesting to you. And yeah, basically what the autoscaling is all about here is, so generally in Kubernetes, in the control plane of Kubernetes, there are several core components, and one of them, the kube controller manager, what he does is it does a control loops. And you don't need to know what a control loop basically is, but imagine one example. So all your objects, yeah, in Kubernetes, for example, deployments, all your objects that you care about, deployments, stateful sets, replica sets, they have one particular YAML, one particular setting, which is the replica count. And there is a controller, there's an ongoing loop, which actually what that loop does is it makes sure that the replica count is as we have set it to be. And why am I saying this? Because the exact same logic applies for the horizontal pod autoscaler. There is a control loop in the kube controller manager that is designed there and put there to manage all the horizontal pod autoscaler objects, so that what we have defined in terms of autoscaling can be synchronized with what there is in each and every node. And this is autoscaling. This is horizontal pod autoscaling, and we need to know how to define this object in a way that it's basically efficient, and we don't need to make other configuration in the future. Just let the application roll out itself. I have pointed out one particular setting here. I hope that you can see it well in your screen. but this setting is one. There are several settings on a cluster level that you should think about, and they're all settings in the Kube Controller Manager. If you have the opportunity to actually set those yourself, this will be a very good thing to do and to note about. But horizontal path autoscaler has one setting which actually can tune the sync period of this control loop that I have been talking about. And by default, it's 15 seconds. Like 99% of the time, you don't have to think about it. But if you are that 1% of a kind of person, you can tune it to be a bit lower or something like that. But basically, what are our goals when we try to make autoscaling? We basically want we don't want to be over-provisioned. We don't want to be under-provisioned as well. And also, we don't want to have a flopping state, which is, for those that are not aware what flopping state is, this is being under-provisioned and over-provisioned all over again in short periods of time. So, for example, this can happen for many reasons, but for example, we have not chosen the metric that is the most correct for our example, for our autoscaler, and it is lagging. So it is not showing the it's not showing what's happening right now, but it has a bit of a lag. And then we are under provisioned for some time. Then the metric kicks in, and then we can actually trigger an autoscaling, but then it's too late. And several seconds afterwards, we can go back to the initial value, and this process is triggered all over again for basically indefinite period of time. This is a flopping state, and this is very hard to actually realize what is going on and hard to deal with. But this talk is mainly dealing with some hard stuff, so I hope you will get the idea how to deal with it. But yeah, how? What we can do in all those three things is tune and work with the scaling behavior. This is something that's very new in Kubernetes, relatively new, but we can do it. And we can have, we can tune and work with the metrics themselves, the metric itself, and the thresholds that we set to our autoscaler. But we don't have the opportunity to actually change the algorithm. The algorithm is something that is set, and trust me, it's not your problem. So it's never the algorithm. The algorithm is simple enough. We'll talk about it in a bit, but you have all the tools you need to actually make the magic happen.
Before you start with the next slide, can I just ask you that you are aware that we have limited time here?
Yeah, of course. I was under the impression that I have a bit more, but
no.
Okay.
I just want to make sure you're aware of the limit. That's all.
Yeah. Thanks for reminding me that. I will be brief with the few slides. As you can see, this is a deep dive, and I will be diving a bit quicker this time. But so I wanted to share one very big milestone in the special interest group autoscaling in Kubernetes. It was in version 1.18, and I have put a QR code here, which points to the PR, the pull request that was actually merged. It's a series of pull requests, but never mind that. So in this particular change, they added very big control. They opted in for us to be able to tune our autoscalers with and actually change the policy a bit that can do the autoscaling. So this is something that we should be mindful about. And I have shared an example of what this change was all about. It's we can set this in the spec of the autoscaler, with which we can actually limit the step with which we scale up or down. We can tune the stabilization window. That's the option at the bottom that I have shown. Previously, it was a cluster option. It was a flag to the Cube Controller Manager, but nowadays you can set it as a per object level setting. So the stabilization window is something very important here, because each time you trigger the logic of the algorithm in the autoscaler, you can basically set to the object, just relax, just take a big breath. So, for example, we've done a huge autoscaling. We have double the replicas we used to have in several minutes before, and we do not want to scale them immediately to the replica count before, and that can be actually achieved by setting a bigger stabilization window, just to make sure that we have a bit more time for future such events. And this can be also tuned, the step with which we trigger down the autoscaler is a bit smaller than the triggering up. This whole example that this slide shows. Just a quick URL. This is the whole options that the horizontal port autoscaler has right now. But another disclaimer: just do the calculation. So you should be aware of all all the settings that you are, even the defaults that have been set. And one particular example that I have in mind is that so you have a metric system, for example, Prometheus underneath, or Thanos, as my example will show. And this system has granularity. Sorry, it triggers, it scrapes metrics, for example, in 2-minute intervals. So it doesn't make sense to make the step of autoscaling less than 2 minutes, because you will basically have double the scaling interval until the system, the Kubernetes logic, can acknowledge any change in the metric. So this is the simplest calculation you have to do, but there are many more. And when you spend the time to actually check the settings in the previous slides that I've shown, you'll see all the other. Yeah. So the algorithm, you see how simple and how cool the algorithm is. This is something that you cannot change I think up to the latest version I checked, but something that is very easy to understand, in my opinion. You have the desired replica count, which is a multiplication of the current replica count with 2 variables. The 2 variables are the current metric values. So what the metric you care about currently shows, and what we want to be the threshold. So the desired metric value is the threshold, and it's simple enough. So if the current metric shows that we have, for example, this 200 milliunits is, for example, 0.2 of a CPU. The current metric is this, and our desired metric is 0.1. Then we need to double the replicas. This is simple math. And if you are under provisioned, it's the same logic will trigger a downscale. And yeah, bonus about autoscaling, I will be very quick about this one, but it's very important as well. So imagine we have the perfect autoscaling, perfect horizontal port autoscaler that the second that it wants to create new replicas, it does. But then the replicas spend 2 minutes, 5 minutes in pending state because we are unable to provide the proper virtualization underneath. So what we can do is actually have our ready machines that are have a buffer in machines, have a buffer in space in our clusters that can actually provide us with a bit of breathing room, and this can be done in Kubernetes with preemption. Yeah, it was an alpha. I think now it's a general availability feature in Kubernetes, but I think you still have to opt it in. And what the preemption combined with pod priority would mean was that you create a priority class. Basically, a priority class would be something that defines how much priority of one object differs from the other object. And if you enable preemption, if a priority with lesser, if an object pod with a lesser priority, if an object, a pod with a higher priority wants to be scheduled on the system and there is no space, it can move another object with smaller priority out of the way. This is very cool because you can, in my example, I have set a negative priority, which doesn't matter what the priority is, as long as it's lower than any other pods. And this can be a blank deployment. I have set a blank deployment. Actually, it was an autoscaling deployment as well. It was checking to be 10% of the whole system, to provision a 10% buffer of the whole system. And once a new autoscaling the autoscaler triggered scale up, it moved the other pods around. And also you can think about the Docker cache, because imagine you trigger a scale up, it triggers a new machine, and this machine does not have your application ready to run. The Docker in your application is on a Docker image that's many gigabytes large. And there is something you can do. This is something that I have particularly very much like to do, is to make imagine a daemon set that immediately after a machine spins up, actually downloads an image, a Docker image, just to refresh the Docker cache, the local Docker cache. And then it doesn't do anything else, and it goes away. So this can actually, in my measurements, can actually improve the autoscaling for up to a minute, depending on the image size. But there is no silver bullet. So there's not a thing that you can do and save all your problems. So that's why my intention for this talk was just to have to go over everything I know that can be of importance to you or to anyone who actually wants to deal with autoscaling. Second thing we need to talk about is the metrics itself. So in the horizontal pod autoscaler, you have the opportunity to actually define different types of metrics and combine them so that your application has the best knowledge, the horizontal pod autoscaler has the best knowledge when to scale up or when to scale down. And this is something by default planned to in Kubernetes, but not enabled. So if you install a cluster, there is not a default tool that can actually feed metrics to the system, except for from some corner cases. For example, as far as I know, in Gkey, in the Google implementation of Kubernetes, there is a metric server, which is a default. But if you install a vanilla Kubernetes server, there is an opportunity for you to actually create an adapter and feed some metrics. And one thing that you can do, there's numerous adapters right there in the internet. Metric server is one of them. It's the default, but it's limited in terms of metrics. You have in metric server only a CPU and memory, the core resources metrics. But because we're in CNCF and we are all fond of Prometheus and Thanos, we can actually have an adapter that was a community project several years ago by Soliros, and it was, I think, donated. I'm not sure, by the way, but it was donated to CNCF, and now it's under the CNCF projects, and is the Prometheus adapter. It's very easy to use and lightweight tool, and what it does is it's an intermediate layer between your it makes use of the API aggregation layer of Kubernetes. It extends the API of Kubernetes with several other features, and one of them is just to show your metrics as an API call of when you deal with Kubernetes. I'll show you in a bit. And all you need to know, I think the three best things that you can think about when you set up this adapter is it's logical. You have the Prometheus URL, and in our case, it can be the Thanos URL, and maybe a Cortex if you're using Cortex, the Cortex URL. It's something that supports PromQL, basically. Then you have the metrics max age. I've put this one here because this is the setting that actually knows what your metrics resolution is, and you should be very careful when you set it. It should be higher than the metrics resolution. So, for example, you scrape on 1 minute basis. This metric should be at least 2, something like that. And the config file. So, a config file is what metrics do we actually feed to our system. And there's example. Yeah, I have spent a lot of time talking, so I'll be quick about this one. But there are 3 types of metrics that Kubernetes actually defines, can accept. And the first one and the default one is the metrics, the resource metrics. This is something that you can see when you're GKE or when you have the metric server installed. And they're very useful but very limited because there are only 2 types of utilization metrics that you can define. They're all resource metrics, so they're CPU and memory. And as you can imagine, not all of your applications can trigger a scale up or scale down event just by CPU and metrics knowledge. But nevertheless, this is something very cool because if you can use it, you can if you can define this properly with some kind of adapter. Here we take these metrics from Prometheus or from Thanos in my example. You can actually use your monitoring system to know about your cluster, and your cluster to make decisions based on this monitoring system. And you can use utilization in the threshold. So you want, it's simple enough to define a threshold. You want 50% utilization, that's it. And then the system can do the math. And also 2 other cool things is that you can, I have shown at the bottom of the page, you can use kubectl to actually actually make an API call to the Kubernetes system that transfers the call to the from the aggregated API to the adapter, and then the adapter translates it to PromQL, returns a value. The PromQL returns a value. This value was transformed, is getting transformed to Kubernetes itself, and then the kubectl return call can visualize a return of the metric to your system. Also, the same can be applied with the kubectl top pods, top nodes command, which basically can, you can use it the same as get nodes, get pods, but it can actually show you how much memory and CPU are now using, your resources are using right now. The second kind of metric that you can define is the custom metric, which basically differs from the previous one in one regard, and that is that it's not an utilization metric. And what this means is that you cannot set threshold of a utilization. You set a value. So if you think about this metric, you can actually not use one particular metric, but a PromQL. So you can define a utilization from your PromQL. So you can use, you can divide a resource metric by the resources you have on your system, and this example that I've shown is such. So it's not a, sorry, it was not the example I was talking about. In later slides I'll show you. The custom metric is something that you should use, I think, 50–60% of the time when you deal with your autoscaler, because you can actually define metrics like, for example, if you have a HTTP server or an application server, you can define metrics, request rate or error rate or something like that. If the error rate is not 0, you can trigger autoscaling, which it's not something that you can do, by the way. You should do, by the way, but nevertheless, you can do it. And the third one is the external metrics API. And the external metrics, it's something that not all adapters support, but luckily enough, Prometheus adapter does. So you can actually define every metric you want. In my example, I have done a recording rule in Prometheus that actually does a very complex calculation with PromQL. And this example can be very useful because, yeah, we can trigger several different systems that feed the metric to our metric system, and we can transfer this logic to our horizontal pod autoscaling. Yeah, big disclaimer, choose your metrics wisely. Something that I should have mentioned before was that in order for the autoscaling to work properly, the algorithm that I've shown is actually aware of the replica counts that you have. And for example, imagine that you have CPU or memory, or if you're using a custom metric, you have a request rate. The Kubernetes system, the algorithm actually can divide and make an average based on the pods that are actually the replicas that are actually in your autoscaling group. And this is true only if the pod is ready. So this is a very important thing, because if you have not defined the readiness prop well, and it's backfiring for some reason, this will you can trigger the application all you want, the application autoscaling all you want, but it's never going to happen. And second thing is that you can actually combine several rules, several metrics. This is very cool because I personally like to define a safety net rule that's always a good, it's always just a little bit too conservative, but can trigger, if the other metric is not firing up, it can actually do the job. And this is an example of the flopping state that I was referring to. This is something that you also can mitigate by just the PromQL itself. So in the first graph, you see how the metric, this is a metric example, the metric is either 0 or a very big value. And you can actually mitigate this using PromQL by simply setting, using, for example, in my example, I'm using overtime function. You can use rate or some other function that support a range query, and you can define a bigger window in which to normalize things. And this can lead to the example in the second picture. And now the cool stuff. I hope I still.
How many slides do you have?
Yeah, the next slides are few enough, but there are yeah, I think the coolest slides there, because up to now this is a very very boring presentation. I hope it was not, but nevertheless it's very boring because we are talking about very technical stuff. But I wanted to get this out of the way because the next slides will define how your system can grow, and it can grow multi-cloud. It can grow multi-region, whatever multi you want. Because with Thanos, you can do this kind of stuff because Thanos, unlike Prometheus, by the way, I'm not sure how many of the viewers are aware of what Thanos is. I have done previous talks on this one, but Thanos is basically can make Prometheus cool, can make it robust, and can actually make it multi-cloud. It's something that we have done in MariaDB, and something that can scale with bigger proportion that you can imagine. And in this example, but basically, why do we need Thanos and not use Prometheus? We need it because we need our horizontal port autoscaler to be reliable. And the HPA is as reliable as our metrics are. So we need to be able to make sure that we have numerous replicas that show one and the same thing, because if you are dealing with Prometheus, you cannot do this. You can hit the different endpoints and then get different metrics, which can actually confuse the autoscaler. So we can do this with Thanos. And one other cool thing that is the whole point of this presentation was that Thanos can be multi-cloud. And this is something that, from our experience in MariaDB, is very useful, because you can have a knowledge about your application if it's deployed in multi-cloud environment. From one of the clouds, you can have metrics from different clouds. In this example, Thanos is the tool, and because Thanos has one very cool feature, the Thanos query can actually be chained. Thanos query can be used as a proxy to other Thanos queries. You can have like, for example, one mesh of Thanoses that can interact with each other and can share metrics. This is something that can feed knowledge from other clusters to your HPA and make an informed decision to scale or not to scale. And here's an example that I was not able to show this because this is something that's very particular, and I have a little limited time here. But for example, this is something from our, by the way, our production environment. You see that I have blurred out in a very noob way the cluster names. But so we have different clusters in different environments, different providers. You can see here that we have prods, even stage, something that it's cool, but it's not very useful to have prod and stage in terms of HPA. But nevertheless, your metrics can be cloud aware, zone aware, region aware, and even cluster aware. So you can have multiple clusters in one provider, different zones, you name it. And with the knowledge that we have learned in this presentation, we can actually define a perfect metric that is an utilization metric. This one is. So you have a request count divided by request capacity, how much capacity our system can now hold in terms of requests. And we can have this. You see, I have summed it by environment. And if we go back, environment is something that is, in this environment, we have different clusters from different clouds, from different regions. So we can, if we are under-provisioned somewhere, we can trigger new pods, new replicas in somewhere else. This is a pitfall, but you have to be mindful, because you have to define the second step that I have pinned out here. You have to define a very particular set of policies that can limit your steps, so that you do not have over-provisioning. And this is a particular example. We scale very quick in all the clouds, but we scale with just several pods maximum. And finally, you have to think about how the traffic will be routed. And this is something that I have not covered in this conversation, in this topic, but you can use different abstractions here. Maybe you do not have to do this, because, for example, in my experience, we had a job worker that it's not a public service. It's something that actually does the job, and it does not care where it does it, as long as it does it well. So you can think of load balancing as something that is is not particularly connected to your auto-scaling, but it's very important. And by the way, this talk was initially, I heard, the first time I heard about this possibility of Thanos was in KubeCon, I think in Barcelona. I don't know when this was. It was long time ago, but then the example was with a simple DNS, auto-scaling, the DNS that points to different load balancers in every cloud, and there is a pitfall here, and it was that if one cloud goes down, then you have to fix the DNS. So you have to think about this stuff. So it's not out of the box yet. And do you need this? Maybe not. You can decide, because this is something that's very cool, very particular, and it can be overkill. It can trigger a hype-driven engineering. But I think it's very, you should be mindful about these possibilities that the systems nowadays provide, and Thanos as well. And I think I finished in 40 minutes.
Thank you. Thank you very much.
We have a couple of questions,
yeah.
but Orlin...
I'll try to ask them.
let me just mention something that
Go ahead.
I recently realized. So I think everyone who is going to watch this meetup on a recording will have that button double the speed, right?
Yeah.
Okay.
Be polite. Okay. We have a question: how HPA will overcome the slow DDoS attacks and not to spend too much money?
Yeah. I don't think that. Yeah.
Don't feel obligated to answer all questions.
No, of course, this is a very, very cool one, because HPA can be useful in terms of DDoS attacks, but it cannot be the primary primary tool that you should You should be mitigating a DDoS attack with. So it can be something that can actually slow the effects of DDoS, but it can trigger all other issues to your system. So I think using an HPA, well-defined HPA rule set and well-defined metric, you can be quick about reacting when there is a DDoS attack, but do not try to fix this by auto-scaling, but by other means. I think using CDN, using other systems that can trigger an alert that can actually, for example, okay, that's another topic. So it can be useful, but be careful about it. Yeah.
Next one.
Yeah, it's related to the first one somehow. Is it worth switching to smaller Kate nodes when you're using autoscaler?
Yeah, that's a good one. I think you can do this, but it will be trickier to configure. You still that's a different question because if you working in Kubernetes, you have the opportunity to actually be multi-environment in one cluster, to have the luxury of actually put a lot of things in one nodes and be resource efficient. And if you are splitting the clusters, you're opting out from this option, in my opinion. So, but if you have the opportunity to actually, for example, one cool thing that you can use if in Jiki, as far as I remember, you have up to 5. You can use a free-to-use Jiki cluster if you have up to 5 nodes. This is something that do not take. It's something that has to be checked. But if you can, with this kind of approach, you can actually make your system less money efficient, not money efficient, but less, yeah, less costly. But it's something that I think it will be very difficult to configure.
Thanks. And last one, can you recommend a quick way, quick advice to give, quick advice, how you can make the autoscaler to be quick based on the HPA actions?
Yeah, so if you want to, my examples, by the way, showed this, but I've not taken a mental note to share it. But if you want to be quick when scaling up, you have to define the stabilization window of 0. That means basically that, with some exceptions, by the way, there are some settings that you have to know. So as the first, yeah, so you have to be, you have to set the stabilization step to 0. That means that the moment that the HPA actually finds a metric that's above the threshold, it will trigger a scale up. But then you have to think about the metric resolution, because the metric resolution can be up to 2 minutes in my experience. Some systems have it up to 5 or something like that. This is madness, because then you have to wait 5 minutes to this one. So then you have to feed to this particular metric. You have this possibility in Prometheus to actually pinpoint one metric and scrape faster for it. So I have done this enough. I have done this in the past. I have set a 10 seconds scrape for one particular metric in Prometheus with 0 stabilization, and that in theory should give you like 10 seconds at least reaction time in terms of horizontal pot auto scaling. Yeah.
Thanks. Thank you. All right, it's about to move on to the next one. It's about observe and measure endpoint availability using Envoy. And take it away.
Hey, folks. Tonight we're going to talk about observing and measuring endpoint availability using Envoy in virtual appliances. My name is Toma Petkov, and I'm going to co-present with my colleagues Vladimir Mikhov and Nikola Kaludov. We are currently supporting, upgrading, and maintaining Envoy in this year. So let's jump in. First, managing a virtual appliance. Let's start with what is a virtual appliance. Virtual appliance is a bit similar to a Docker image, but you have a software package that contains the operating system itself. So the whole thing is deployed in a single container, and it's on its own. You don't have operating system sharing or some things like that. And this is a predecessor to Docker and Cloud Native. So what are the contents of our virtual appliance? We first are using Photon OS as an operating system. And our virtual appliance has many smaller services that the client would reach using the different URI prefix. In complex workflows, the services work together to achieve more complex goals. So if one is down or sleeping, we have a big problem. Our mission is to make these legacy services 99.99% available. This would be much easier if we had some stateless services which we could just put behind Envoy and load balance them. And if we want more some resource, we just duplicate some service, and they're all alive, always available, done. Our legacy stateful services sadly cannot do such thing. they have to keep their state in memory sometimes or in a database, and they have to survive no matter what, on their own or not. Introducing Envoy, we decided to use Envoy as an edge reverse proxy to put in front of these services because it's very well optimized and very feature rich. Also, it's very easily pluggable. So we have all these cloud-like features that Envoy gives us for free. How do we use those to observe endpoint availability? And well, endpoint, if I say service A will respond on /SDK, that's for me an endpoint. Okay, how to observe the different endpoints? We have two main approaches that Envoy gives us. We first have access logs, which mainly help us to reduce the debugging and have a clear log on what network calls have happened. You see the access log later. And then we have metrics, which help us measure the overall health of the system and the availability of different endpoints through time. Okay, let's go through some Envoy specifics. You probably have heard of most of those. If a client does a network, an HTTP call to port 443, it will first reach the listener inside Envoy, and then the traffic will go from the downstream listener through the route in yellow to the upstream cluster, and finally it will reach the service, and the endpoints will be available or not. Okay, Vladimir Mikhov will talk us through which metrics we use and how we collect them.
Yes, thank you. So, the metrics we use, in order to explain this, first we need to understand some more of Envoy specific terms. We measure the upstream services, and we need to understand what the upstream is. So the downstream, this is the client that makes a request to Envoy, and it wants to reach a service that's behind it. And this service is called the upstream. It's called the upstream because it's the producer of the data, and it's sending the data down the stream to the downstream. And the metrics that we use are the upstream response metrics, which are very standard, the count of the 200 responses from our service, and all the server errors that the service returned. Let's first start with the major thing we use for debugging, which Tomas said, the access logs. This is very verbose, but it gives a lot of information, like as you can see here. It has a timestamp. It has the HTTP method that the client used. It has the endpoint /SDK in this case. And it has the response from the service. And we know it's the response from the service because of this string right here via upstream. This means that the service actually got the request and responded to it. It's not cached, it's not, the service is not down. It's there and responded to the request. But this is, those metrics are nice for debugging, but if you want to observe the real-time state of our appliance, we're going to need some metrics that are more aggregated and that we can collect real-time. So this is where Envoy statistics come in. this is an example of how you could get the statistics of any envoy. If you abstract yourself for a minute from the Unix domain socket here, we get them from the admin interface, which Envoy provides. On the /stats endpoint, and we get them in Prometheus format. This is just for the example. But we can get a lot of useful stuff, like the amount of total requests to our endpoint, in this case 593. We can see the amount of 200 responses, which are 479 in this case, from the same endpoint. And we can get all of the server errors, which the service returned, which are 112 in our case. In order to achieve this, in order to get the admin interface running, you need to do some configuration of Envoy. In this case, we have it listening on a Unix domain socket because the admin interface does not support authentication, and we need to secure it in some way. Here we have the permission. This socket is URL readable. Anyone can read and write to it, which is not very secure. So the way we secure it is with the permissions of the directory that it's in, the var run envoy directory, and we use a utility in Linux called tmp files. I think it's present on every major Linux distribution. And the way it manages temporary files, volatile files that contain data. And you can set permissions and extended permissions on them, which is what we do here. We create this var run envoy directory with only the envoy user being able to read and write to it. But then we give the metrics user an extended permission so it can go into that directory and read and write into the socket. Yeah, so only the metrics user can enter this directory and read from the socket. Also, we configure our statistics so that Envoy collects only the statistics that we need. This is done because if it collects all the statistics, which is the default, it increases memory consumption by about 50 megabytes, which you might not want to afford here. And the overall architecture of our solution, because we have a virtual appliance, we have the virtual appliance with Envoy on the front, and then it sends the data to a metric sync service. Currently, we're doing that through the admin interface that I showed you with. If you were in Kubernetes, you would probably do this with Prometheus. Then the metric sync service sends it to the cloud push service, which knows where all the analytic solutions that want these metrics. It knows how to convert the data to their format, which they recognize. In our case, we're using Wavefront, so the service is sending data to a Wavefront proxy, and then the proxy is sending it to Wavefront. So now that you know how we collect our data, Nicole will go through how we use this data to compute the availability.
Thank you very much, Vladi. Yeah, so this is the fun part. We know how we collect the data. Now, how do we use it? And there's a lot of philosophy here, so bear with me. Right, so let's start with how we use it internally to help ourselves reach the goal that we outlined in the beginning, which was to reach 99.99% availability in our legacy service that has to survive on its own. So in order to do that, we are already established how we observe the availability. Now we want to aggregate some sort of per day metric for the availability of our bleeding edge, up-to-date code, right? Because every day we're making changes and we want to track how we're doing. So imagine, if you will, that we had a way to build this graph in the lower right. What can it do for us? By the way, it shows a data point for each day. So each day we have some run that has established that our system has, in the worst case, X availability overall. Now, we can use this to track regressions, obviously. If somebody's introduced a bug or something that reduces our availability but doesn't do anything else, doesn't crash our service, it wouldn't have been detected previously because we aren't measuring the availability, but now we are. So for this endpoint, we have noticed that on these days, the availability has gone down. We can intervene, we can analyze what happened, and fix the issue quickly. Secondly, we can measure improvements. If I've, for example, written some feature that's meant to improve the availability of the system, I want to know exactly how much it has managed to improve it by. And lastly, we can make sure that we are meeting the service level agreement. So now that we are trying to modernize our service, go into SaaS, that means that we're making some sort of promises to our clients. And we want to make sure that we are keeping those promises. One of them is going to be availability, so we want to make sure we're staying above this line. But how do we get this graph? Well, there is a bit of trickery involved, but so imagine we already have some sort of long-running test because we were a legacy service, right? So we were measuring performance with that. Now we're also measuring availability. How do we do that? This is an entire run, an 8-hour run for one day. And over that run, we have gathered a bunch of successful and unsuccessful responses. You remember the 200s and the 500s. But those mean nothing like that. So what we do is kind of a heuristic method. We split them up into little time chunks that are evenly spliced apart. And we aggregate and sort the successful and the unsuccessful responses for each one of these slots. And then we get the percentage of successful responses, well, the successful requests for each one of these slots. Why do we do it this way? Well, because usually when availability goes down, that's, it isn't dispersed over the entire run. It's usually it's clustered in time. So we want to find those problematic time slots, and when we go in to diagnose the issue, we can find them very quickly this way. Right, so how do we get the overall score with that? We just take the lowest, well, in this case, the lowest 20% of availability slots, and we average over them. That's how we know the availability in the worst case of our system. And we want to measure the worst case because, we want to have a guarantee that we're always above that. In this case, it's a terrible score, but just bear with me. Also, we have a second metric, which is the percentage of perfect regions. These are the regions in time that have observed no failures at all. And you can think of both of these metrics as complementary to each other. So if either of them goes down, we have a problem, and we have to look into it. Also, you will notice that there is an empty region. For internal usage, we don't care about these. We only care about failures. We want to find out why failures are happening. Right, so this is internal usage, but the more fun stuff is how do we deliver this data to the users and to the service reliability engineers, which will be wanting the data live, not over a contained environment 8-hour run. They want to see for the live service that's running currently, what's the availability right now? And they want to be able to react quickly if it falls. So imagine that this data that you're seeing is a live feed frozen in time for the last 10 seconds. And so we can ask the question, what is at this moment? If this is at this moment, if the last 10 seconds are at this moment, then we are about 50% availability. But looking at this, it seems more likely that the service is actually at 0% availability, because in the last 3 seconds, we've got all failing requests. So what's happening here? We have to be dynamic about what time frame are we defining as the current moment. The second problem that we're facing, and also bear with me for this philosophical question, what if there is no data recently? So as the famous proverb says, if a tree falls in a forest and no one is around to hear it, does it make a sound? Which relates to our case perfectly. What is our services availability when nobody is using it? I mean, for instance, some endpoint is currently not being used and hasn't been used in the last few minutes. Is it available? We don't know unless we ping it, but you don't want to be pinging it because, I mean, in a live environment, you can't just go around pinging stuff. That might overload the system. So we have to somehow, you know, get a metric out of this. Is it 100% available, 0% available? Is it undefined? We have to give the user something. Well, let's make the question a bit easier. What is our services availability if there's been only one request? So not 0, just one request recently. Well, if recently we have a failed request, does this mean that our service is down? Not necessarily. It could just be not a failure. So we cannot extrapolate data from this just one simple request. Well, you've seen this problem before, actually. This should be a familiar problem to everybody because this is actually a famous class of problems in statistics. For instance, imagine that you're buying something from Amazon and you have this article that has a 5-star overall rating. So does it mean that it's a perfect product? Well, no, it has only one review. We cannot extrapolate its actual quality from just one sample, and we definitely cannot do it from 0 samples. So we have to come up with a solution. And finally, let's get to the to our solution. On the right, you'll see that Zoom later is kind of the data that we're giving to the service reliability engineers. We have to give them just one number for each endpoint. So how do we do that? Well, one way to do it would be to average the last X responses, whatever you configure X to be. It doesn't matter, but it works quite badly because imagine the service goes down. You have to wait a few requests to go by until you figure out the actual availability of the system. You could instead average over the last X seconds, but then you get into the problems that I just talked about. You might not have any samples. What do you do in that case? Well, that's actually what we're doing currently. And in order to circumvent this, for this endpoint, for instance, that's /ls, we are giving them the averaged availability over the last 30 seconds, but we're also giving them a bar chart for them to see how many requests this is based on. So if there has been little sample size to base it on, you can have that in mind. But I think we can do better. I think we can just give them one number. Let's look at some better approaches that we are considering. One is a weighted average over the last X responses. So you average the last X responses, but the ones that are further apart in time, the ones that are further behind in time, those will have less of a weight in the averaging algorithm. So this kind of combines the past two algorithms, and it works quite well in simulations that I've written. So we are certainly considering this one. But also there is the very complicated method of Bayesian updating, or Bayesian, depends on how you pronounce it. Definitely a very interesting way to do it, but it's very complicated. It's statistics and maths. If you want to know more about it, definitely look into 3 Blue, 1 Brown's videos of probabilities of probabilities. It goes over all of these topics of how you calculate the actual value of something from samples. And that's pretty much it. So thank you very much for watching our presentation. You can see links on how to contact us. Definitely connect with us on LinkedIn, and I have my website up in there. And if you have any questions, we are here to answer them right now or online. Thanks.
Thank you. I have one. How do you configure your Envoy?
Right.
I don't know who is the person to answer that, but I'm contributor to Contour, which is a control plane for Envoy. So I'm super curious about that.
We actually have our own control plane. We had before Envoy, we still had a reverse proxy, but it wasn't scaling well. It didn't have all those benefits of Envoy. So we have the API of the old reverse proxy, so services can tell us, hey, somebody is going to listen on port 8080. So we use our own APIs to configure Envoy, and we have pretty much our own custom control plane for now.
Okay, thanks. We have a question from the chat. What is the use of service sync as an intermediate for metrics? I'm not sure who can answer that.
Yeah. Well, this one, the service sync, the metric sync is used.
It says service sync, maybe it's a...
The metric sync service, I think.
Could be.
Yeah, so this one is used because we already had the infrastructure around it. We already had the service that pushes it to the cloud. And this module that gets the data from Envoy is part of another service that is part of the same service that manages Envoy, the so-called control plane. So we already have had all the infrastructure around it. We just needed to add a little bit of code in this service, so that's why it's there.
Okay. And I have another one. Envoy is an open source project, right? And what part of your development is an open source as well? Or you, I'm just not aware what exactly you're developing, to be honest. So, so how much of your work is open source?
As of this moment, there's not much work. We are trying to put upstream to Envoy some of our solutions, but it's kind of a battle sometimes because we don't have that much of open source experience, and we're just getting into that, just dipping our toes.
Okay. Questions? Okay, thank you very much. Should we close?
Yes. Go ahead.
Okay, thank you everyone for being with us. It's a bit over the hour, so thank you for your patience. Thank you everyone for your talks. It was a super pleasure to listen to you. I hope you can see each other in person next time. That will be in 1 month time. So we'll skip October because of KubeCon and OpenFest. So we have some topics for the November edition in 24th in the Acronis office. If you feel like talking on our meetups, please submit your talks. We can get in touch and discuss how we can organize all that. So thank you and see you next time. Bye. and